I'm Russ Altman, and today Martin Fischer tells us about how the business of construction is being revolutionized with new tools and approaches. We're going to talk about where current construction methods fall short and how emerging new methods create a vision for a more efficient and effective set of practices for construction. It's the future of construction. Most of us live in environments that are designed and built by humans. This is often referred to as the built environment, and humans have been in the process of building their environment for more than 2,000 years, with societies worldwide outlining the principles of construction. Now you can imagine the current approach to construction, which builders from 2,000 years ago would still recognize. Someone decides they want to build something, a house, a bridge, a road, a theater, a stadium. Someone designs the project in dialogue with the customer who specifies their requirements and their preferences. This is iterative and can require many rounds of design and revision before everyone is happy. Eventually, a structural engineer must look at the designs and make sure that the structure will be stable, safe, and obey the laws of physics. It won't fall down, it won't fail, and the construction is all possible. Based on the design and the plans, there is an estimate of the cost and a detailed plan of what will happen when: excavation, making a foundation, building the exterior, fitting the interior, water, plumbing, electricity, etc. Then a manager must actually implement the plan for construction, finding the folks who will do each piece of work, scheduling them, making sure that the raw materials they require and the equipment they use are on site at the right time, and managing unexpected events so that the project comes in on time, on budget, and pleases the customer. Anyone who's been involved in new construction or remodels would recognize this sequence and knows many stories about how it can go wrong. People change their mind. Supply issues mess you up. There are surprises, like you find out you're on top of a former hazardous waste dump. You have labor challenges, bad estimates. Worst of all, the building is no good. So even though we have done construction for hundreds of years, there are great opportunities for improving the processes, making it faster and more efficient. Martin Fischer is a professor of civil and environmental engineering at Stanford who studies these issues. Martin, how did you decide to focus your research on methods for construction and how to improve them? Martin, thanks for being with us today. Let me start out with a basic question. What got you interested in construction and the engineering discipline of improving construction?
It was really a comment of a friend of my dad's back in Switzerland when I was 8 that I had forgotten until I had to pick what am I going to study. And he had sort of casually mentioned, how people ask, what do you want to be? And a pilot or whatever, or a doctor. And then he had said, bridge engineer sounds kind of a fun, like a really interesting job. Bridges are needed everywhere and it's kind of a cool structure. And I had sort of, somehow it had lodged itself into my brain, and that came back to me as I was thinking, what do I study? I loved languages, I loved math, I loved science. And I thought, well, everything asked me to specialize and leave this other thing off. At least that's what was my perception at the time. But wait a minute, bridges, there is this thing, bridges, you need to understand the physics, it's for people, you need to understand the environment. It's needed everywhere in the world. So so that's really what was sort of the thing that pushed me over the edge and said, okay, I'm getting into civil engineering, construction.
So that's great, and these origin stories are always fascinating. Now, in the area of construction, it's very interesting because I think many people who don't think about construction might believe that it's a well-understood, very static. We've known how to do it for literally thousands of years, going back to the aqueducts and the Pantheon, and so and many people have been involved in construction projects where you have an architect and then you have plans and then you build it. It goes over budget. You pay the extra money. It's late, but then at the end you have a building that is functional and everybody's happy. But actually, from looking at your work, it's clear that there are many problems and opportunities for improvement. So could you highlight for the person who doesn't think about construction what they might expect in the future that is not part of regular practice now?
Yeah, first of all, less disruption. So more predictability, I think, is sort of the first. My wife's family lives in southern Wisconsin, so we've done the journey from O'Hare on I-90 for years, and there was construction on I-90 for decades. It was basically a joke, and I thought I felt so embarrassed being in construction, right?
Yes.
Having to drive through backups, and we see this still in too many places. So I think less disruption, not only in road construction, and we're doing a remodel at home right now. Everybody that has done that can knows about that disruption. So more predictability.
So you're saying that all of this typical experience that I made a little joke about and that you're describing both in your home and in the I-90, that doesn't have to be the case?
No, it really should not be the case. It just drives me crazy that we still suffer. I mean, we shoot ourselves in the foot if I put my construction hat on, right? Because what many of my colleagues in the industry don't somehow seem to realize is that we are our own worst enemies. We are competing with each other, but in fact we are competing for the marginal dollar of the agency that has to decide, are we putting this money into education, are we putting into where are we going to put the tax money, and of the consumer who has to decide, where do I get most value for the money, in a remodel, or am I going to go on a family vacation in Hawaii? And I see it for myself more often than not. I choose not construction, but I would if I knew I will get what I want and when I want it and for the money I need. And I mean, we do see many projects like that. So in the future, I think we will be able to define better what it is that we really want. So there sometimes we have to look in the mirror, and even I would say it's even as a big client like Stanford that has lots of buildings, we don't always do a good job there. Some of my colleagues might disagree, but I'm pretty sure. But and then have a really clear path to successful project.
Okay, so one of the things I wanted to get out relatively early in our conversation is you have talked about a kind of a progression of models that when we build a building, there's different levels that you can think about a building, and you've kind of formalized this. And could you take me through exactly what do you mean by models for a construction project, and what are those levels, so we can start to think about how you conceive of these construction projects?
Yeah, so I'm frustrated with our industry. But at the same time, we also have to recognize that these are very challenging undertakings that require the input and expertise of many people. And so the first set of models is really to let us see what the future will look like, because you're creating a different future.
Right.
And so these graphical models, these 3D models, sometimes also 4D models are important in terms of the steps, illustrating the steps we get there, are key in just getting everybody on the same page so that it's not your idea or my idea. We have something to focus on and work together. That's hugely impactful.
And this is something we even see, even at the house level, when you're building a house. Very often now, an architect will bring you on the laptop so you can do a virtual walk through the space. Exactly
that kind of model. So in terms of deciding what we want, that's very, very useful. And in terms of bringing people together, having them collaborate in a timely, productive manner. The next level is to look at the information that's behind it. So we need to know. So we can see, this is a door, but the computer doesn't know that this is a door. Okay, there's my colleagues in computer vision are making that possible now, that we can automatically identify that, but still, most systems in use today, the system doesn't know this is a door, but this is important because we need to manage that door. We need to order it. We need to check its delivery. We need to, and for other structures, for other parts of a house or building, we need to do structural calculations or energy-related calculations and so on. So we need the information from the building to feed into various kind of calculations. So that's sort of the next level. We call that building information model.
Okay.
And that's pretty much the standard in good projects today.
And that is also often represented in a computer.
And that's in the computer. So, so everything, the big transformation that's really happening is that we are taking really the analog world of construction into the computer. And you might say, well, finally, but the reality is that we really have not had the computing power to display, to create a model for a big building in a time that is fast enough, so
Right.
it's less than the building time.
Right.
And the computers that are, and then the network that are fast enough to transmit that information back and forth, right, let you see it, etc. So the next level is, it gets kind of annoying when you just have to like label things and put things into a computer. Here's a wall, here's etc. We'd like to put some rules there, some parameters, and say, in my bedroom, I just want always, I might change the dimensions a bit, but I always want a queen size bed to fit between the two windows. You could put that there, computer is dumb, basically. And so when you give it this rule, then you should make the room size, make changes, maybe a little wider, whatever.
So these are like the human preferences that would make a room nice and pleasant versus a pain in the neck to be in. And it's different from everything. Like, yes, you can look at the picture, you can do the information model, but you'd like to be able to tell it these things so that it never gives you a proposed configuration that is silly.
Exactly. Put the rules there, the things that you really care about in the computer. That's sort of parametric model. Because there's so many different choices we have, and then it's about preferences, and that gets us to the next model where we can get feedback on, like, you get this performance, that performance, in terms of maybe daylight or flexibility, you have to change things, or structural performance, or cost, of course, or time to build it, and so on. So there's many of these kinds of predictions. So performance, I call it performance model of our buildings.
So like how well it gets heated, as you said, the daylight, there's all these things about a building that sometimes in the current world, you have no idea until you build it, and, well, at least in my experience, until you build it, sit there and say, oh, it's too bright, or oh, it's too hot.
Yeah, exactly. And then it's very costly to change it, right? And so that's the next level of predictability in terms of performance. Of course we want performance, like it's on budget and schedule, but then we use the building, if you talk about the building set, but it's the same with a tunnel or a road or a water treatment plant. Is it performing the way we want it to perform in terms of energy, CO2 emissions?
Now, I know that, so that's very good. So now we have, so right there I can see what's new, because I have done several remodel projects in my home, and the only thing that was computerized was the pictures of what it would look like. Everything after that was talking and guessing and using the expertise of the person who I was working with. And you've just described a set of levels, all of which I could imagine being computational. And once it's computational, maybe it's faster. But I wanted to ask you also, I know that you've written a lot about not just the design of the building, but managing its construction. And you made some comments earlier in our conversation that there are great opportunities for efficiency in the, okay, let's do this, and then building the building. Can you tell us where the big opportunities are for efficiency there?
Yeah, really come from two directions. One is what I call feedback loops, which are too anecdotal and slow today, so that I get feedback. How did today actually go? Of course, I have my reflection on it, but it's amazing sometimes when you look at the data, what you see versus your reflection.
Right.
So that is happening now with a bunch of different IoT devices, a range of
IoT is Internet of Things.
Internet of Things, yeah. So basically sensors, various types of sensors that tell you every second, every minute what's going on. And that's, of course, fairly complicated. And there's, of course, privacy issues too on projects. But we are starting to get these feedback loops in terms of the construction phase itself. And the same then goes into the supply chain logistics. Are the materials on track? Are they arriving? Because if they're not there, you can't do anything. We see that right now in lots of projects. Then the other is, of course, new technologies like robots and additive manufacturing, so 3D printing. So we're very early there, but we see quite amazing illustrations already, early examples of dramatically safer, higher quality construction thanks to, for example, robots that are deployed not only in factories but on site. So this is really a fun area of technology development, to make robots that work alongside crews, because construction work is really backbreaking work. It's the health and safety aspects for many types of work is not good, and so that's one area where I'm very excited. in terms of the future potential there.
Yeah, so let's talk a little bit about the human-robot or human-AI interaction. It sounds like the future that you're imagining for construction will have different roles, and it may look very different. The work site may look very different. Do we have worries about worker displacement, or is it a question of retraining to have... you probably know what humans are good at, and machines are not going to be good at that for a long time. So how do you imagine transitioning into this new world?
So right now, for the foreseeable future, we have a shortage of construction workers, especially skilled construction workers, and we just passed the stimulus that Biden President infrastructure bill. There's a similar effort in Los Angeles County to improve transportation, passed a few years ago, extra tax dollars available there. So frankly, I don't know where the construction workers are going to come from to do all of this work at prices that we will like. Mm-hmm. And so we have to really find ways of leveraging the workforce we have, because people are not streaming into construction in droves, and I can't really blame them the way it's done today. So, but maybe by making it less backbreaking, making it more interesting, making it more productive, connecting it more with digital methods, which our kids have no problem with, we can attract workforce of the future, and we can leverage the expertise we have today to build the things we really need to build. So for the time being, if somebody's willing to engage with these methods, I think go through a little bit of training, and we've seen some good examples. That happened when the 3D modeling came onto the scene, say about 20 years ago, and especially in our area here. A lot of the experienced construction people, say 50-year-olds that had 20, 30 years of experience, they said, I'm kind of tired of being 6:30 every morning on the site, and it's
it's a grind.
It's a grind. But if I learn, if I sit down and learn this digital tool, I can still build. I can build in the computer, and that's really impactful. And they really made a big contribution to advancing the modeling.
So that is a great example where people who you might think would say, get that away from me, I know how to do this, your machines are interfering, they actually embraced it.
Yeah. One of the funny anecdotes in that respect, in the early days of 3D model, when people looked at me like, yeah, Martin, you're a little bit crazy, but okay. So finally I convinced this management team of a major contractor, was over in Germany, to give it a try. Said, what do you have to lose? Come on, please, the future has to be this way. And so then they said, okay, all right, Martin, fine, let's go. And then I happened to see three superintendents sitting in their morning break, having a little sandwich. And I thought, well, I'm just curious what they think. So I went over there and said, did you hear, we're going to start working with 3D models here. What do you think about that? And they looked at me like, finally. And I was like, and then I said, tell me more. These are typical crusty-looking construction guys, And I said, tell me more. I said, yeah, well, we work here and we do the job, and we do it as best as we can. On the weekends, we program 3D computer games.
Wow. So
they were like, okay, this is finally, let's go. We can handle this, right? So I get just surprised again and again, right, by what people are actually wanting to do, can do, are willing to do, right? I think we often underestimate that.
Next, we will discuss more about new methods for organizing and implementing construction projects, including some exciting projects in places like Slovakia, which are embracing these new methods before others. Welcome back to The Future of Everything with Professor Martin Fischer. Martin, you have painted pretty exciting picture for how construction projects might work in the future. What are the barriers to implementing this vision?
Yeah, wow. Okay, where do I begin?
Yeah, exactly.
So one thing we do have to recognize, and I have to give credit or respect to all the people managing projects, is it is a challenging endeavor. To align the material flows, the information flows, the money flows, the wishes, desires, the changing wishes, desires, and conditions, etc., and regulations, of course. So people know how to do that with the methods today.
Yes.
And they have to be competitive on every project. So if I'm saying, yeah, but the future can be much better, so I'm going to put a little money into my project budget to pay for moving into the future. Well, I'm not going to win any more projects because somebody else will not do that, and they will be more competitive on that project.
Right.
So this is definitely a challenge, and that's where we have seen some very inspired clients that say, the future is definitely more exciting,
and they're willing to pay for it.
And they're finding ways of paying for that. Even some public clients have had some innovation funds, have given project teams a little bit more budget to create a little bit of breathing room, right? To try something and to learn it and gain confidence. And so that's. But then I think we should also see just more demand. I mean, because I see a lot of finger pointing, people saying, yeah, that's all very nice. Let's say a designer saying, Martin, well, the benefit is all by the builder gets the benefit, or the client saying, but this is for the designers, etc. Everybody pointing to somebody else.
Right.
And it's like, no, please, come on, you guys have to be professionals here. You know, what do you imagine in 10, 20 years? How are you going to get great employees, etc. So you just have to find a way of embracing, these new methods.
Yeah. So what about? I know that construction is a serious business in terms of safety. There are inspections. I built a pool in my backyard, and I wanted to build it up to code, but it took it 15 years to pass the inspection because of one 2x4 in the heater hut that was too close to the chimney and therefore a fire risk. Many people have these. So what does the government have to do? Is there a role for the government to kind of catalyze this in order to benefit society, or should they stay out of it?
No, I think they have a very, very critical role in terms of the life safety aspects of everything we build. I mean, super critical.
Right.
And actually, just like after this interview, I'm going to a meeting that also started yesterday with the Deputy Prime Minister of Slovakia, who is here with a small team to envision this digital future for his country. And what they have done is that when they came to power a year and a half ago, the business individuals came to them and said, this is just crazy how long it takes for us to get anything permitting. Like, this is hindering our country. This is hindering the progress. And then they looked at things and, okay, let's look into it. And they found that, like, this is for bigger structures, but there was like 84 steps you had to go through. And it took, like, for a factory, like 9 years to get it done. And they have streamlined that down to 13 steps at most that you have to do. And to shorten for major structure the permitting time to about 9 months maximum, for smaller structures to a few weeks, by harmonizing basically regulations, by saying, okay, no, I mean, come on, it's crazy that this village has a slightly different regulation than that village, and then the inspector can only do that. And I mean, no, this is, at the end of the day, construction has to satisfy the laws of physics,
yes.
And they are not so different from different places.
And that sounds like a very compelling story, because there are real results that people care about in terms of time to completion. Probably it was cheaper and presumably it's just as safe, if not safer, than the product would have been.
No, it's safer because the regulations are harmonized. They can be really good because somebody looked at them carefully, not just, they had like 2,900 jurisdictions that looked at construction. I mean, it's the same in California, it's the same in the US, right?
So let me ask you, I don't even know this, is this a local decision? Are building permits and building regulations typically done at the county, city, state level? I don't even know that.
All of them, yes,
oh,
yes,
my
yes.
Goodness.
Yes, so if you're building in Mountain View, then that may be different than what you can do in Palo Alto or Cleveland or Chicago, whatever. So there's codes at the state, at the country level, but also at the community level, and that's for life safety,
yes.
Green building codes, requirements for. I mean, so it is tough. As a builder, if you want to be efficient, you got to build in a geographic quite wide region, but you
need to know all those rules.
You need to lead all of those things, because and then you look, any one of those things makes you look like really silly or stupid. Like, how could you not know that?
Right.
Yeah, but this was one of like 2,000 things I was supposed to know.
Yes.
You know.
So to finish up, there's two things I want to hopefully get to. The first is, it occurred to me that the unit of construction is something that your vision might impact. And what I mean by that is, are we talking about a single building or the plan for a block or the plan for an entire neighborhood? And it seems to me that if you have these modeling profiles, and if they're in a computer especially, there's an opportunity for kind of an integrated design of the built environment, which would require, it would be complex, but it might have huge benefits to the people who are living or using these built environments. So I wanted to ask you if there's a trend in that direction, or if that's just too hard to even coordinate.
No, that's one of the other things that excites me very much about the future, is that we call it in our lingo multiscale models.
Multiscale.
Where meaning we have models that, you need to understand, say, your heating system in your home. But then, of course, your home in the context of the other homes, your home in the neighborhood in the context of the city and so on, and next with the infrastructure, etc. And all of this does change over time. It looks static on one day, but if you look at it over a few years,
right,
then it changes a lot. And one of the experiences I had, the guy living across the street from me used to be the marketing manager for Keyhole, which was the predecessor for Google Earth. And he would take me over and say, Martin, I got to show you something. And because it was super cool at the time, right, when they started. But then he said, I go to conferences and then I show it. And then people say, oh, can I look at my home? And then, okay, zoom in. Wow, this is amazing. Now it's like, normal, but 15 or so years ago, that was not so normal. And then he says, the reaction, it doesn't matter where I go, the reaction is always the same. Zoom back a little. Oh, this used to be so much nicer. Nobody is truly happy with how things developed.
Right.
And I think that's where we have to just demand better visualizations and scenarios of the future, so we can come together as individuals, communities, and say, that's the future we want. And let's make that future happen. And that's now totally within our power, because we have these, as we call it, multiscale models, or they're merging. And that's a very exciting development.
Thanks to Martin Fischer. That was the future of construction. I'm Russ Altman, and this is The Future of Everything on SiriusXM Business Radio, Channel 132.